Good morning, people. I see a lot of students have joined in. Ishwari, good morning. Ajit, good morning. Atharva, good morning. Tejas, good morning. Kriti, good morning. Bini, good morning. Gaurav, good morning. Nikita, good morning. Manjari, good morning. Prajwal, good morning. Prachi, Yoga, Harshal, Harshal, very good morning. Purnima, good morning. Swarata, good morning. Rasika, good morning. Chinmay, a very good morning. Saket, good morning to you as well. Sandesh, good morning. Praveen, good morning. And Aditya, good morning. A few more, good morning. Sakshi, Ganesh, Muskan, all of y'all. A very good morning to y'all. I got a bit busy, and that's why I had to rush up with my morning tea as such. Well, to start with where we had left last time, let me start sharing the screen right away. And if you remember, we started with this slide last time, and for today, it is just a revision for today. Okay, but I would say that this slide includes a lot of information with regards many things that one learns in geography as well as otherwise as well. The length of the days and the nights in the respective seasons is one thing. The angle of the sun's rays, I will just enlarge it so that we concentrate. Okay, you'll see the angles. Okay, and let me tell you, I did tell it last time also that these angles reverse when you have the respective summer and winter as far as the respective hemispheres is concerned. Then this is the circle of illumination, and when I'm looking at the circle of illumination, you will see that it is very informative. Okay, we are looking at it from the North Pole or the South Pole as such at different positions. And this first position, wherein you have the summer of the Northern Hemisphere, you will see that one thing, that one, okay, as far as 66.5 degrees longitude, the Arctic Circle is concerned, the zone of illumination is just touching this circle. So this interprets into a geographical fact that on this day, you're going to have the start of 24 hours days a day, or rather I would say you have a 24 hours day on or along this particular, the Arctic Circle. That is the geographic fact about the mathematics and the geometry behind it. And then you'll see that as far as the equator is concerned, you'll see that if you're seeing the equator here, okay, you'll see that it is cutting the equator. Okay, you'll see that it does not happen so as far as the Tropic of Cancer is concerned, but you can see what is happening as far as the equator is concerned. So on that day, you'll see that the equator has an angle of 66 degrees, or rather the sun has an angle of 66 degrees at the sun. And of course, you'll see here again, during the southern hemispheric, it's December solstice, it's more or less the same as such. This is something which is very interesting. This is in fact the path of the day or the sun of on a particular day. Actually, what is done is they take this path for the whole of the year, and they decide as to how, if we are to tap solar energy, I am forgetting the name of that particular diagram, but I'll try to get it tomorrow. They'll plot the whole path of the sun throughout the year, and let me tell you that the angle of the solar panel, if we are tapping solar energy at that particular location, will be matched accordingly. In fact, in Pune, all those who are living in societies which have solar panels installed, or you have them in your houses as well, it could be for heating of water, or it could be for energy purpose as well. That's electricity purpose as well. You'll see that the angle of the solar panels is towards south, facing towards south. It's not horizontal, or it's not this way. It's exactly like say if the sun is from here, the the angle, the present angle of all the solar panels in and around Pune would be facing south. So all that working has to be done, taking all this into consideration. And why that has to be taken into consideration, you'll see that the insolation changes accordingly. You'll see that as far as the insolation is concerned, it is highest along the equator. This blue line is 0 degrees. However, you'll see that the cloudiness along the equator does not translate into that much amount of energy, or I would rather say that that energy tends to be absorbed in formation of the clouds, and then the clouds do block the energy coming from the sun. So you'll see that particularly if we are considering this to be, I think this is, if it is falling towards August, April, May, June, July. So this could be a diagram for the southern hemisphere, let me tell you. So if it is dropping here, okay, if it is dropping here, that's April, May, June, July, August. It could also be, we'll have to check this particularly, but then if it is dropping, it has to be the winter in along these periods as such. But you'll see that on contrast, you'll see that 90 degrees, though you have the highest of insolation here. We are going to do this in climatology, I've already said earlier as such, but the start of light, the polar day starts in May and it ends in September. So you're left with only 6 months. Okay. And that too, initially the insolation is much less. So the actual highest insolation would be somewhere between mid-May to let us say mid-July. Now, having said this, let me tell you that this intense insolation is not enough, because a lot of this is reflected back in what is called as albedo, which is reflection of the sun's rays from the surface. So all these things have to be taken into consideration. You'll see that 30 degrees, 60 degrees, you'll see that again, while 60 degrees has a higher amount of insolation, it actually doesn't translate into that much amount of energy. Remember, the amount of insolation and the amount of energy is going to be interestingly different. So you'll see that the total amount of energy which would be available along 30 degrees and around latitudes would be significantly fruitful, important, and that is why you will find the tropical regions around this particular area. So this was it, and then immediately we went into the geological time scale. As I said, the geological time scale, as students of BSc, somebody did ask that how much detail do we need to go into this. I would say that you don't have to go into much of detail, and I would say that you remember this as a story format. As far as you remember it in a story format, you would be able to reproduce it again as to how it all started. And I remember I did ask for suggestions as to how should we be screening a documentary if I don't get these these suggestions, because frankly speaking, I am not a technical guy. And if any one of y'all is actually looking into computers and softwares and apps, etc., as such, please let me know as to can we use any particular app to screen that particular documentary for whole of the class and so on and so forth. If that could be done, that how the Earth was made, the documentary that I talked to you about last time, is in fact self-explanatory, and you would remember significant amount of information from that particular documentary as such. So that can be done. By the way, yesterday I have posted a very interesting talk by Carl Fabin. I'm forgetting his surname, but he is the president of the Ocean Institute, and he speaks excellently well as far as oceans, ocean resources. And I've given a description. I've typed a description about that particular thing. Believe me, I had heard about this 15 to 20 days ago. That's before Diwali, and I thought of visiting it again, and I visited it twice, and I made points out of that lecture, and so that I could write a brief, I could text a brief information about what he speaks about. And anybody interested in environment, actually all of us should be interested in environment, besides our own subject as such, but anybody interested in environment should go through that, because it gives you a sense of catch into what actually is happening wrong. And say not everything that we consider wrong is wrong. Okay. If you go into listening to that, and let me tell you that don't listen it for the sake of listening it, or for the sake that I have told you to. If you really have a liking and you need to understand what is wrong around us as far as the environment is concerned, you can it's around 1 hour 26 minutes, of which this guy starts speaking at around 6 minutes, and he stops his speaking around the 70th minute. Let me tell you that the first 20-25 minutes he is describing everything around it, but he gets the attention of the audience after 30 minutes. I won't recommend you all to jump to 30th minute as such, as at the same time the last 15 minutes of question answers are equally important, the way he answers it. Okay. And you can watch the way he has made us slides, because that is what you're going to do in time to come. Okay, your FY, SY, TY, you'll be attending competitions, etc., or after TY you would be attending interviews, etc. So the way he is presenting, the pauses he takes, and the way he looks at the audience after he takes every pause, and what he means out of that particular pause, these are minor things which need to be understood if you want to be a good public speaker. I have a habit of looking into people when they speak, and learning the best out of them. So I would recommend this. Those who have seen it will of course vouch with me. Those who have not can visit this particular link. Along with that, I have posted 2 links on the geological time scale. Uh, you can have a fair idea about that. As far as one recommendation one of the students had last time we met was the week before that, basically, because this Tuesday or last Tuesday we did not have a lecture, for the fact that I was on leave on that particular day. So the Tuesday before that, somebody had suggested me that could you please revise this with us. I will give you everything of this in a nutshell. The age of the Earth, let us say, is 4.6 billion years to say. Of these 4.6 billion years, the last 0.6 billion years, which could translate into 600 million years, is what we have a lot of details about. Okay, this is called as the phase wherein you have larger form of life. Life moves from water to land, and of course we had a discussion about whether whether life came up on water or whether life came up on land first. I believe that it came in water, basically because till the point the ozone layer developed, the land had a difficult time adjusting to the ultraviolet rays of this life on land. I would say had a difficult time adjusting to the ultraviolet rays that harmed the, and they kept pestering the surface of the earth, the land surface of the earth as such. So these are the last 600 million years. But what happens before that? You'll see that the period before that is called as the Precambrian eon. Okay, the Precambrian eon as such. The Precambrian eon is further divided into 3 parts. The earliest of it, the first 500 million years of the formation of the Earth, is called as the Brisconian, because everything was so very liquid and ductile, I would say, as far as the surface is concerned. We did not have hard surfaces. You had volcanic lava and magma erupting and lava flowing into various parts on the surface. We could not say this is land, and of course there is no question of water with that high temperatures. Temperatures started to cool down after the first half a billion years of the formation. And that phase wherein all these things, the first of the land shields, as they are called, they came up. This is called as the Archean period. Okay, this for sure does not have indications of life. Okay, we have very less amount of rock left on on the surface of the earth today as far as the Archean is concerned. Now, you would say that, sir, how could you say that with with you informed only about 24% of the surface, which is land, and how do you know about the ocean? How can you say so about the ocean surfaces? Let me tell you that while we say that land is a new form, if you read through the theory of seafloor spreading, which we will do minorly, it says that as far as the ocean surfaces are concerned, none of the ocean surfaces is older than 100 crore years. Okay, which is a very small period. So the ocean surfaces are always into formation and reformation and so on and so forth. Land pieces, some of them are very old, but we are left with a very small amount of them. That is the Archean thing, and we hardly have any, so to say, um, traces of life in this. Okay, because life started emerging only after 1 billion years of formation, and that too was in a very microscopic format, single cells, at a microscopic level only. You'll see that it's only after say around 2.5 billion years ago that or say around 3 billion years, or let us say 2.5 billion years of formation, that the rocks from that period indicate at some form of life. Indicate this again is microscopic, but this indicates that the journey of life has begun on this particular planet, and that is why this particular time is called as Protozoic. Zoic, we said when we started with the geological time. Zo is life. Okay, so towards formation of life is what you can say this particular period. And during that period, life has evolved. And actually, the larger form of life, when everything had more or less settled on the surface of this planet, uh, 600 million years ago, we start with the Paleozoic era. Paleo, old form. Zoic is basically the form of life, and Mesozoic is a mid form of life, of evolution, and Cenozoic is the modern life. Mammals represent the Cenozoic. Mesozoic, we have seen that it's the dinosaurs who represent it, and Paleozoic, there is no particular representation, but amphibians, you could say, life had just started moving from the water onto the land as such. And you'll see that as far as Paleozoic is concerned, it is believed that the Aravalli ranges in India are of that particular age, the Paleozoic age. These are again fold mountains, but so many millions of years of hundreds of millions of years of erosion have brought them to a smaller size, particularly when you put them to comparison as far as the Himalayas is concerned. The Himalaya was supposed to be coming much later as such. The Paleozoic is further divided into periods. Okay, the Cambrian, Ordovician, Silurian, Devonian, and so on and so forth. Now, obviously, I can understand at your age, and for the first time, you are looking into these geological time scales and these names of various periods as such, the Triassic, Jurassic, Cretaceous, and the Paleogene, Neogene, Paleocene, Eocene, Oligocene, Miocene, Pliocene, and the Pleistocene. These are tongue twisters on one side, and of course, learning all of them is going to be difficult. When I was a student, I had my mechanisms of memorizing them, in the sense that for the Paleozoic thing, I had coined this word cos DCP. Now, it's a very funny way, but then you have to find out things, isn't it? When I have to memorize something. So cos was from trigonometry, cos, sine, cos, tan. So cos C for Cambrian, O for Ordovician, and S for Silurian. And DCP is basically a designation in police, Deputy Commissioner of Police. That is how I tried to remember that. Now that struck me basically because my father was in police then. And then Triassic, Jurassic, Cretaceous, I just memorized them, and I remembered that Jurassic is the most stable period. So Jurassic is in the center, and Triassic is up, and Cretaceous is down. And then as far as the Tertiary period is concerned, the Paleocene, Eocene, Oligocene. If you take the first words of them, PEOMP. Okay. Now I said that okay, POEM is a poem. Now I just twisted the other two, PEOM, poem, and I come back to P. Okay, so that gives me the tertiary era. Later on, I realized that this art, okay, I don't know how many of you all know this, but this art of making longer concepts into sentences or terms that you can remember easier is called as mnemonics. If you now see towards the bottom of your screen, I've written a mnemonic there. Okay, and let me tell you that it spells Mnemonic, mnemonic. The M is silent. Now I realized this, and I came across this much later when in fact, when I had started teaching in colleges, that the whole of the geological time scale, whole in the sense the large scale life, can be abbreviated into a very interesting sentence that is formed. And how does it go? Camels often sit down carefully, as if camels are old. Camels often sit down carefully. Perhaps their joints creak. The joints, they creak in the sense they you have that tuck awaj. Okay, that is creaking, or it pains, let us say. Persistent early oiling. Okay, now this is a mechanical concept, but as I said, that mnemonics may not necessarily have a meaning. You have to create a meaning so that you remember this. Persistent early oiling might prevent permanent rheumatism. Rheumatism is, of course, the disease which is related to joints and cartilages and so on and so forth. Now, when I read this all, okay, it makes some sense, but not absolute sense. Camels often sit down carefully. Perhaps the joints creak. Persistent in early oiling might prevent permanent rheumatism. Now, if you look at this, C stands for Cambrian, O stands for Ordovician, SIT stands for Silurian, D stands for Devonian, C stands for Carboniferous, and then perhaps is Permian. They are Triassic, J, Jurassic, Creek, Cretaceous, and then you come to persistent, which is basically Paleocene, and then you have the Eocene, Oligocene, Miocene, and the Pliocene. Okay, so this is how you and of course the last two, the Pliocene, and of course the um, Pleistocene as such. Okay, so that is how you put all of it together. Now, further going into the details, as far as the Zoic periods are concerned, Paleozoic periods are concerned, they end with a IAN, Eon, and you'll see that the other thing that is difficult to remember is the tertiary and quaternary period as such, that ends with a scene, cene. Somebody was also asking about what type of questions will be asked. Now if it's an MCQ, I would ask questions which would check your um, logic into this, and that is why I'm giving you these logics as such. I would give you four terms, and I would say which of them is a period, and which of them is an epoch, and so on and so forth. I would say which of the three is oldest: Paleozoic, Mesozoic, Cenozoic. So you have to remember that as such. What is the period before Cambrian called as? It's Precambrian. What is the Precambrian period nearest to the evolution of life on this planet called as? That's called as Proterozoic. So it's as simple as that. And if it comes to subjective questions, a short note on the measuring the age of the Earth, or further say how do scientists go into um, how did scientists go into measuring the age of the Earth, which could require say an answer of around 100 to 150 things. Now, as far as the geography of this is concerned, I already said that say the Aravallis in India are much older, and you'll see that when we speak about that guy Alfred Wegener, he speaks about the Pangaea and the Panthalassa, which happens during late Carboniferous and Permian. So before Carboniferous, let us imagine that we had the Panthalassa. It splits into two. You have the Sea of Tethys in between, and you have the Laurasia and the Gondwana. which takes a few million, 100 million years to form, and say by then it is Permian, and then there is further splitting, etc., etc., etc. And then you'll see that towards the late Cretaceous, the Indian peninsula has started moving up, and then it is passing a hotspot. Now, what exactly does a hotspot mean? I have that for us, and we'll be doing that as well. It passes an hotspot leading to the formation of the Sahyadris, and then you'll see that the last phase, that's Cenozoic and the Quaternary, the Himalayas went into formation. In fact, you go into the geology of the Himalayas, they further tell you when does the greater Himalayas, when does the Himadri, and when does the Shivalik come into formation, and so on and so forth. So there are various ways to understand and remember this. You can choose your own way to try and memorize this as such. We don't have, as I said, we don't have to go into details, but knowing about this in the basis of what is older, what is this, and what is the scale. The Paleozoic is half of the total period. Let me name 345 million years of the total 600 million years. That is something that we need to remember. Okay, then you'll see that the Cenozoic period, the latest of it, is not more than 60 million years, only 60 million years. Within that, you have the Tertiary and Quaternary. Within that, you have the Quaternary, which is what, 20,000, 25,000 years old. So that sense of scale, as geography students, we need to have that sense of scale. Okay, what was long, what was short. Okay, when did the say dinosaurs, when were they there, and what were the possible reasons that they went extinct, and so on and so forth. And as you read, you tend to gather things also. So as you gather, you tend to attach them with a reference, and the moment you attach them with a reference, you'll see that it tends to be interesting. Remember that this whole thing, okay, the whole details of what we speak about, okay, in detail, this whole mnemonic that we have formed is just 600 million years. Now, within that, if we imagine when man comes up, it's very interesting to know when man comes up, and particularly once again when we are putting it on the scale. We're going to go into that. Let's see. But as I said, yeah, I wanted to speak about the hotspots, and it is believed that the Sahyadris are basically an outcome of the peninsular plate traveling on a hotspot. Now, what is a hotspot? You can see here. I'll take you down one by one. Okay, now this is what an hotspot is. You'll see that from the core you have a sudden plume. Now, if you have ever seen or at some point of time, at any point of time, you come across a very huge flame burning, you watch that particular flame, and you'll see that when that flame is burning, okay, you'll see that those yellow things will, as they are called as the plumes, they will leave the core and they come up. Okay, so something similar to that happens with the core. You'll see that the outer core, which is liquid, it sends up such a plume of magma, and it keeps rising from the mantle. It's easier because it's hotter, and of course the mantle is not that rigid, and of course it's moving towards lesser of pressure, so it zooms up. Okay, that's called as the rising plume. You'll see there, the first one is the rising plume. That's called as the head of the plume. And when it reaches the base of the mantle, where the asthenosphere is where it forms a hotspot. Now, a hotspot is going to have millions and millions and millions and billions and millions of tons of magma, and it is always waiting to come up, or possibly once it starts coming up, once it finds a vent to come up to the surface, it continuously keeps on coming. At times, it is supplied by this magma from the core. At times, it is cut off, and then eventually it dies. But before it dies, it has erupted. I would say billions of tons of lava onto the surface as such. And while now these plates are in motion, this third, I want you all to concentrate on this third thing here. You can see that as far as this ocean surface is concerned, you'll see that if the hotspot is continuous, okay, and it spreads very fast, it would fall what is called as the volcanic basalts in the second diagram. But if it stops and goes and stops and goes and stops and goes up again, you'll see that it accumulates at a particular location. And in fact, this location is very similar to what you can see here. Okay, you'll see that this hotspot hotspot kept on giving out, and you have the chain of volcanoes, and it is the same chain of volcanoes that you can see in the Hawaiian Islands. You'll see that the present Hawaiian island is here, but the other islands, okay, the Pacific plate is moving, and you'll see that the mantle plume is giving the supply of magma, and you'll see that it keeps on coming up. Okay, I would say the movement has stabilized significantly. One or the amount of magma coming out has increased, and that is why you'll see that the uh, present Hawaiian Island happens to be the largest of the island, and it has active volcanoes on it as well. Okay, so this is how it happens. You'll see that you can see here also in that circular thing. The Hawaiian is last of it. Now probably it will move ahead, and you'll have a new island which may come up in a span of some tens of millions of years. It is not only the only one. You'll see that you have several hotspots all over the planet, and you'll see that one famous one is the movie 2012, I suppose. Yeah, 2012, which was based on the Yellowstone hotspot. You'll see that this is the Yellowstone hotspot here, and it was based on that. I don't know how many of you all have seen the movie 2012, but it's a very interesting thing on plate tectonics, etc. Of course, they've taken a lot of cinematic liberty there, but it's very interesting. A fiction movie, I would say. Similarly, on climatic change, I would say the movie that comes on Star Movies, that is The Day After Tomorrow. Then, of course, you have these volcano and tornado. All these movies relating to climate extremes are also there. But hotspots are an interesting thing. And now, coming back to the point of our interest, if you can see my cursor moving here, this is Madagascar here. This is South Africa, South Africa. To the east of South Africa, you have the Madagascar island, and you'll see that here this circle is the Reunion hotspot. It is believed that when the Indian plate was passing over the Reunion hotspot, as such, the Reunion hotspot gave out a lot of magma, and it is that particular magma which came up in the form of the Sahyadris. Now, because this came from deep down, you'll see that the Sahyadris are made up of basalt and not granite as such. Another thing that is being debated amongst scientists is that where did the other half go? Okay, because you'll see that those of who have traveled to the top of the Sahyadris, okay, the Ghat areas, many of you all may have. I won't claim all of you because I see students who are yet to come into Maharashtra. They are attending lectures from their own houses as such. But then those who have traveled into the Ghats, you'll see that at the top of the Sahyadris, you look into the Konkan region. There is there is a very steep fall that's called as an escarpment. Now, people believe that that escarpment is nothing but the Madagascar island. So, let us say that while the Indian plate was on the Reunion Island, it was larger. One thing. Secondly, it gave out a lot of magma to the formation of the Sahyadris, which was the right side and the left side as well. The left side were left behind for strange reasons we still don't know, because this is not a confirmed theory. This is just one of the views that scientists have, while the rest of it kept on traveling further to form what is seen to be the present peninsular India as such. So that is as far as hotspots are concerned. So another thing that I can this is how hotspots tend to be created, and that is how the plates move as such. Okay, you'll see that this is a hotspot here, and while new ones keep coming up, okay, the plate is pushed, and then when it comes in touch with another plate, the heavier, the denser of the plate, of course, will slide down. You can see here that the plate is sliding down. While it slides down, you again have a pressure on that plate, and then it melts and it forms magma. And this magma again comes up, and it flows out in the form of lava. So you have very many a times very near to the coastal areas, you have volcanic mountains. Within fold mountains also you could have volcanic mountains. So this is a very interesting complex thing that tends to happen. These arrows here basically show the convectional movement. Okay, the hotter ones come up, and of course the comparatively cooler ones go down. That is how the cycles tend to happen. Okay, you'll see that this is one plate, this is another plate, And then, of course, this is the third plate. So this is the association. We're going to go into the details of this when we move into crustal formations. As I said, it's interesting to understand how we could be relating these things on time as such. Now, if we say that every second was equivalent to 1 lakh years, how much time do we say? Okay, say this is uh, uh, say the 24 hours, okay, and then you see that as I said, that more than 90% of the whole thing is occupied by Precambrian area, and the Precambrian era also is divided into two: the Archean one this side, and the Proterozoic is this side. So around 2100 hours, that's 9 o'clock, starts the Cambrian thing, and then you have the Paleozoic era, which extends up till what 1030, and then you have the Mesozoic era, and you can just imagine how late the Cenozoic era, also called as the age of the mammals, is concerned, and which leads into the last of it, Quaternary, where man has is supposed to have evolved, and that's not more than 17 seconds of the whole 24 hours. Okay, in fact, a more interesting one is this. Okay, they assume that the whole geological time scale from the first day that the earth was formed to the present second, let us say, whatever the time right now would be, they all equate that into 24 hours. Now, if I'm going to put that into a 24-hour clock, how interesting would that get? Okay, you'll see that the first 3 hours of that whole period, say, I would say the first 500 million years, that which we call as the Precon era, you'll see that it's all about meteorite bombardment and very, very hostile conditions on the surface. Gases like sulfur, helium, hydrogen, very prevalent on the surface of the planet. So the first 3 hours of that particular 24 hours is occupied by that thing happening on the surface. Gradually, things cool down, and say by around 4 o'clock in the morning, you have the origin of life. Remember, this origin of life is meaning very, very microscopic organisms. Okay, and the present fossils that we have, the oldest of the fossils possibly, which we have traced today, is around are those which are around 5.5 hours and 36 minutes as such. Okay, then we come to early morning, 6 a.m. What happens at 6 a.m. and after 6 a.m. what happens? Okay, you'll see that during this particular period you have abundant banded iron formations. Now, actually, it's very difficult to understand what banded iron formation are unless and until you watch that movie, How the Earth Was Made. I would not go into the details of that, but it is believed that a lot of iron was there and it was spewed up during the rock formations, and that made the waters that accumulated very green in color. It was only when this iron got oxidized that and it got liberated, that waters slowly started turning into the bluish color that we have. The seas at around 6 a.m. till 9 a.m. were very greenish, pale gray in color, let me tell you. All this was happening between 6 a.m. and let us say noon time. So just imagine, okay, from midnight to noon, 12 hours have already gone, and nothing significant is happening on the surface of this planet. It is only around at 2 o'clock in the afternoon, you can read it here now, only around 2 o'clock in the afternoon that we have started having what are called as single-celled animals, that's algae, 2 o'clock in the afternoon. Half the day is already gone from midnight 12 to noon 12, and another 2 hours to that. Okay, half the day is already gone, and you have just started having algae around it. Okay, then from 2 to 3 and another 3 hours go by. It's only after that, at around 6 o'clock, that sexual reproduction evolves in plant and the possible animals that we had at that particular point of time. Okay, so that's another interesting development, a leap, I would say, as far as life formation and evolution of life is concerned. And after that, after why they have written it here is basically because it's after this that you start having, though it's only a quarter of the day now remaining, in the sense of 24 hours, of course. Uh, it's a very important stage, I would rather say, and that is why after this you'll see that, however, still for another say 2 hours nothing happens, but you'll see that around 8:30 in the night, evening rather, I would say, you have seaweeds, okay, and then you have jellyfish at 8:48. Okay, now jellyfish are that old. Those of who have been to Goa recently, or who have been reading through news from Goa, you'll see that along the beaches of Goa there have been cases of jellyfish stinging the tourists there as such. Okay, so from that time to date, jellyfish have been there on this particular planet. Then at 9 o'clock, the oldest of the fossils that we have, you remember that stonish thing, and then I'll put up a thing tomorrow if I can get into trilobite. The oldest of the proper fossils that have been found are of trilobites. Okay, it's that shelled thing. It's very similar to that movie, Mummy Returns, or what was it? The first of the Mummy series as such. Those bug-like things. Okay, trilobites look like them. Okay, then this team believes that land plants come later. So you'll see that it's around 52 minutes past 9 o'clock in the night that land plants come up, and it's around 10 o'clock, 10:30, that you have coal swamps. So possibly this is the Carboniferous period as such. Carboniferous period. Okay, then dinosaurs, which we consider to be very, 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 very old, are coming up only at around 11 o'clock. Just see, I'm reminding you of the scale. Midnight the previous day, noon the next day, evening the next day, and of course we are coming towards the close of that particular day. It's 11 o'clock, only 1 hour to end. And you'll see that we have started speaking about dinosaurs at 10 hours and 56 minutes as such. So you can imagine the scale at which when we are speaking about the geological time scale. That also emphasizes the importance of learning the geological time scale, so that we actually understand that dinosaurs, which we say are very, very old, actually compared to the age of the earth, they are not very old. In fact, another hour passes by, and it's only then that you start having mammoths. 11:39, in fact 20 minutes to go to the present day, only 20 minutes to go to the present day. And you will see that mammals are seen here on the surface of the planet. 11 hours and 39 minutes as such. And in taking that into consideration, when we are to speak about humans, just see 11 hours 58 minutes and 43 seconds. So it's just the last minute. It's just the last minute that we have been there on this particular planet. And now relating it to the talk of Professor Carl that I have posted yesterday, Safin, Carl Safin, that I've posted yesterday. Just see, in that 1 minute of time that we have been on this particular planet, how severely have we affected so many things on the surface of this particular planet. Isn't it something that we should be thinking about? How fast we are depleting, exploiting, and causing and are a cause to extinction of various species and various resources as such. We are overusing so many things. Okay, without considering, we are not even sharing it with our fellow human beings. Leave aside sharing it with other animals. Okay, that's very unfortunate. Okay, we have classified ourselves into say developed countries, developing countries, underdeveloped countries. Within the countries, we would say we are classified. We are so fond of classifying things. We have classified the geological time scale, but unfortunately the society also tends to be classified into class, creed, gender, you name it, and we have done. We class ourselves age wise also. We class ourselves gender wise, sex wise also. Classification is our best occupation, I would say. Okay, we classify ourselves ethnically, we classify ourselves caste wise and whatnot, and to get hold of things. Now just imagine to public as such. And just imagine at any point of time in your life when you have tried to catch a place in a bus, and then it so happens, hypothetical situation, it so happens that during that what happens is you have someone who jumps in front of you and he occupies the window seat, and then you get into a fight with that particular individual, and you fight and you fight and you fight. Eventually, if that individual gets into the bus, any questions. I don't know what technically went wrong, but believing that not much has gone wrong. If you're seeing me right now and you have any questions as such, you could just ask me those questions. I don't know how long I have been off. Okay. Were you able to see the broadcast? Can somebody type me some responses? Have you been able to attend the lecture properly, or what was it? Okay, okay, okay. Uh, yeah, it reads, Yuga says that, is anyone able to? Yeah, even I had some problem at my end. I don't know why that happened. Uh, Not for 3 minutes. Okay. Okay. I thought we missed out the whole lecture as such. Okay. If it's for 3 minutes, of course, I'll get back to that and I'll see when it stopped screening. And well, we will attend to that issues now. Anjali says that yes, sir. Now I don't know. Yes, sir, in the sense you are able to see me or not able to see me. And similar thing is with Sheetal also. She just says yes, sir. I'm not able to know whether you are able to see me or not see me. Mm, there's some issue. Anyway, we'll call it a day instead of just beating around the bush. We'll call it a day, and let's see. Tomorrow we will go into the details. I'll check where the broadcast went wrong, and I'll carry from there. So that's all for the day. Uh, have a good day. Thank you very much.